Alright, in this video I'll be teaching the sandwich theorem, the application to limits. And does the sandwich theorem state? It states that limit of theta as theta tends to 0 of sine theta over theta equal to 1. And also limit as theta tends to 0 of theta over sine theta will also give you 1. So how can you apply this theorem? How can you use it? Now, let's consider this example. If you have a limit as y tends to 0 of sine 3y over 4y. Now, all you need to do at this point is to just introduce 3 over 3 to this function. If you have 3 over 3, which when you divide, you still have the original equation, what you get is 3 sine 3y, and you exchange, you have 4 multiplied by 3y. Now, this means that this side will be equal to 1 when you extend the limit, which is what I did here, and then you can bring out the 3 over 4. And finally, you have 3 over 4 multiplied by 1, and this will give you your final answer, which will be 3 over 4. Now, coming to this other example, also when you have limits as t tends to 0 of 2t over tan t, we all know that tan t is the same thing as sine t over cos t. 2t over sine t over cos t, if you do the math very well, you have 2t cos t over sine t, and you can break this down into pieces, break it into 2 parts. You have t over sine t, and then you can factorize the 2 out, and then you have limit as t tends to 0 of cos t. We all know, we know that cos 0 is 1, and then this using sandwich theorem, you will get 1. Then 2 multiplied by 1, and also by 1 will give you 2 as the final answer. And the final example, which I will do in this video, it looks a bit complex, but one of those things you can do is you can pause the video for a moment and just do what's it called, check through the example, look at it time and time again, and it will help you. Now, this is the explanation. If you have limit of x plus x cos x over sine x cos x as x tends to 0, the first thing is you break this into 2 parts, bring this to one side, and then open the addition sign and take this to the other side. This means that the cos s on this side can also cancel the cos s on the other side. You're left with x over sine x on this side, and then you're left with s sine s over cos s. Now, you know that if you open this bracket, there should be a bracket here, there should be a bracket here, there should be a bracket here, and also here. Now, when you open this bracket, you can have limit of this separately and the limit of this separately, and then you know that this you can apply sandwich theorem to get 1, which we'll do at some point. Also, for this side, you can still break this side down because you have x over sine x, and then you have cos x. So you can break it down to what? To limit of this, and then if you open the bracket, you have limit as x tends to 0 of x over sine x, and also you have limits. You have limit as x tends to 0, 1 over cos x, plus, this is an addition sign, plus limit as x tends to 0, x over sine x. Now, when you do this, this will be equal to 1, this also will be equal to 1, and when you multiply 1 by 1, you're still left with 1. Let me break it down a bit. You have 1 plus 1, which will give you 2 as the final answer. So thank you very much. You can send me your comments and questions in the comment box.